Hello and welcome back to another session. Today's session is going to be about VPC, Virtual Private Cloud in AWS. VPC is the most important component of networking and it's the backbone of security system in AWS. And it has far more concepts to understand than any other AWS services. So the plan is to divide this service into 4 different sessions. In today's session, we will learn the basics of VPC and how the different components communicate with each other. And in the coming sessions, we will look into the aspects of security, pricing, and a hands-on session to create VPC from scratch. So let's get started. So VPC is a virtual network where you can launch your AWS resources, and it's similar to our traditional networks. The main difference being in traditional networking, you run your own data centers, whereas here AWS runs the data centers and provides a scalable infrastructure. As you define your own network space, you have more control over the privacy and security settings. Let's see a diagram to understand it well. Imagine this is your entire AWS cloud space where all your data centers and infrastructure lies. Now within this vast space, you can launch your own virtual network which is dedicated to your account in any one of your AWS regions. VPC is a regional service, so all the components within a VPC should lie within that single region. Once you have your own private network, you can divide them into smaller divisions based on IP address range called subnets. These subnets can only reside within a availability zone. So you can launch 2 or more subnets within a single availability zone unless they do not have any overlapping IP addresses. That is, you can launch another subnet in the same availability zone A here. However, a single subnet should stay within a availability zone and it cannot span across multiple availability zones. So subnet 1 here should only be in availability zone A and it can't span across availability zone B. After creating subnets, you can launch all your AWS resources within them like EC2 instances, load balancers, databases, and more. You can make a subnet either public by connecting to internet and launch resources which will need access to internet, or just leave them private and use them for resources which will not need any internet access. So now we have the basic setup of a VPC. Next, we can move on to how these components within a VPC communicate with other components. Communication in VPC is mainly determined by where you direct your network traffic from your subnet or gateway. You can specify the exact routes where your network traffic should flow by using a route table, which is simply a set of rules with destination and target endpoints for network traffic. So the basis is a route table, and you can use this to specify the routes within a VPC, which is called a local route, or with the internet using Internet Gateway or NAT Gateway. Also with other VPCs called as VPC peering. You can even specify how your VPC connects with other AWS resources using VPC endpoints. However, there are only limited number of services supporting this at the moment. Finally, with remote networks outside AWS, for example, connecting AWS VPC with your private data center. This can be done using VPN connections. Whenever you launch a new VPC, it comes along with a router and you will automatically have a main route table attached to the VPC with the default route which has the destination as the IP address of the VPC and the target as local. This allows the subnets within the VPC to communicate with each other. So this is how the components within the VPC are connected. Next use case is to access the internet from your subnets. This can be achieved in 2 ways. The first way is by setting up an internet gateway and attaching it to the subnet through the route table entry. Once an internet gateway is added to the subnet, it becomes a public subnet. The instances which has the public IP address or the elastic IP address attached to it can access the internet from these public subnets. However, instances with just private IP address cannot access the internet with Internet Gateway. This is where the second way comes handy. You can associate a NAT gateway with your subnet, and the instance with just the private IP can access the internet through the public IP address present in the NAT gateway, which in turn communicates with the internet gateway. However, with this approach, it only allows outbound connections to the internet initiated from the instance, and it prevents any inbound connections from the internet. Next in the list is the VPC peering connections. This is one which allows you to set up communications with other VPCs. You can connect with VPCs within a region or VPC in other regions or even with VPCs in other AWS accounts. In all three cases, you have to initiate a request from either one of the VPCs, and the request has to be accepted by the other VPC. Then there should be an entry added to the route table of both the VPCs with the destination as the IP address of the VPC to be connected with, and the target is a peering connection ID, which will enable the instances in both the VPCs to communicate with each other. So the one shown here in the diagram is the route table config of VPC B, which has the destination as the VPC A and the target as the peering ID. The next thing we may want to do is to communicate with other AWS services. This can be achieved by using VPC endpoints. There are two types of endpoints, interface endpoints and gateway endpoints. So both help in connecting with certain AWS services. The diagram here uses gateway endpoint to connect to an S3 bucket. You will need to add an entry to the route table associated with a VPC to establish the connection. The last type of connection is a VPN connection, which allows you to connect VPCs with your remote network. There are 5 options here. The first option is AWS site-to-site VPN, where you set up a virtual private gateway in VPC and customer gateway in your remote network and establish a IPsec VPN connection between the two. The next option is AWS Client VPN, which is a VPN service that allows you to connect the AWS resources as well as on-premise resources. This is done by creating a secure TLS VPN session and connecting your users to it. In case you have multiple remote networks to connect with, then you could use AWS VPN Cloud Hub, which is similar to option 1, however, creates multiple connections instead of single site-to-site connection. Or you can even set up an EC2 instance in your VPC, which runs a third-party VPN software. The last option is to set up a direct connect, which is a dedicated private connection from remote network to your VPC. These are the 5 options to connect your VPC with your remote network. That's it for today, guys. Hope you found it useful. In the next session, we will discuss the security aspect of VPCs, which involves security groups, NACLs, and more. If you have any questions in this session, please let me know in the comments below. We'll see you soon in the next session. Thank you.